Hi all, good morning. Let's start Maths, grade 11, chapter 4. Chapter name is Complex Numbers and Quadratic Equations. Learning objectives. After this session, learners will be able to define complex number, apply the algebra of complex numbers to solve related problems. Introduction to complex numbers. We have seen the equation x square plus 1 has no real solution, as x square plus 1 is equals to 0 gives x square is equals to minus 1, and square of every real number is non-negative. So we need to extend the real number system to a large system so that we can find the solution of the equation x square is equals to minus 1. Let us denote square root of minus 1 by the symbol I. I we call as a iota. Then we have I square is equals to minus 1. This means that I is a solution of the equation x square plus 1 is equals to 0. Now, let us see complex numbers. Definition. A complex number of the form a plus ib, where a and b are real, is defined to be a complex number. For example, 2 plus 4i. Here, 2 and 4 are real numbers. I we are denoting this complex number. 1 plus root 3i, whether 1 and root 3 are here real numbers, and thus I we are denoting this complex. And 4 plus 2 by 3 into I. These are the examples of complex numbers. Algebra of complex number. First one is addition of two complex numbers. Let Z1, we denote complex numbers with a Z. So here let us denote with this Z1 is equals to A plus IB and Z2 is equal to C plus ID. In generally, if you want to add the real numbers, 2 plus 3 means we'll add it up. Similarly, complex numbers A plus IB and C plus ID we can add such that we'll add the real values first, then we add this imaginary values. So sum of Z1 and Z2 can be defined as Z1 plus Z2, that is equals to A plus C plus I of B plus D. So here in the Z1, A is a real number, in the Z2, C is a real number. Similarly, in the Z1, B is this imaginary, plus D is this imaginary. So I plus B plus D, which is again it's a complex number. So addition of two complex numbers is this an complex number. Next, difference of two complex numbers. Given any two complex numbers Z1 and Z2, the difference Z1 Z2 is defined as Z1 minus Z2. That is nothing but addition of Z1 plus minus of the Z2, which already we know this one here. Similarly, multiplication of two complex numbers. Let Z1 is equals to A plus ID, A plus IB, Z2 is equal to C plus ID. Be two complex numbers, then the product Z1 Z2 is defined as Z1 Z2 is equals to AC minus BD plus I into AD plus BC. So here we are first multiplying it, the A and C, then A and ID. So here ID will come here. Next, IB into C is, so BC is here. Next, I into I is I square. I square is minus 1. So minus of BD. So that's why we are making it as AC minus BD plus I into AD plus BC. Next, division of two complex numbers. Given any two complex numbers Z1 and Z2, where Z2 is not equal to 0, the quotient Z1 by Z2 is defined by Z1 into 1 by Z2. So here just we are writing it off Z2 denominator Z2 as 1 by Z2. Next, power of I. We know that I cube is equals to, we can write it as I square into I, because A cube we can write it as A square into A. Similarly, I cube we can write it as I square into I. But what is I square here? I square is minus 1. So we'll substitute I square as minus 1. Then we are going to get here minus I. In general, for any integer k, I power 4k is equals to 1. Why? Because I power 4k, when we multiply with I into I, that is, here we are multiplying I into I is I square. I square is minus 1. Again, minus 1 into minus 1 plus 1. Therefore, I 4k is equals to 1. Similarly, I 4k plus 1 is equals to I. 4k plus 2 is minus 1. 4k plus 3 is minus I. Next, identities. Z1 plus Z2 whole square is equals to Z1 square plus 2Z1 Z2 Z2 square. This is in the form of A plus B whole square. Similarly, we can add the same to the complex numbers also. Where Z1 and Z2 are the two complex numbers. Z1 plus Z2 whole square is equals to Z1 square plus 2Z1 Z2 plus Z2 square. Similarly, Z1 minus Z2 whole square is in the form of A minus B whole square. So, Z1 square minus 2Z1 Z2 plus Z2 square. Z1 plus Z2 whole cube is equals to Z1 cube plus 3Z1 square Z2, 3Z1 Z2 square plus Z2 cube. Here, Z1 minus Z2 whole cube is equals to Z1 cube minus 3Z1 square Z2 plus 3Z1 Z2 square minus Z2 cube. Again, Z1 square minus Z2 square is in the form of A square minus B square. That is nothing but A plus B into A minus B. That is Z1 plus Z2 into Z1 minus Z2. The modulus and the conjugate of a complex number. Let Z is equals to A plus IB be a complex number. We are making this, okay. Then the modulus of Z is denoted with this two standing like this. That is a modulus. Z is defined to be a non-negative real number which is square root of A square by B square. That is modulus of Z is equals to square root of A square plus B square. What is the conjugate of Z? Now the conjugate of Z is denoted by Z bar. Okay. Is this complex number, that is A minus IB. So here we are changing the sign of this imaginary values here. If Z is just A plus IB, then the conjugate of Z is Z bar, that is A minus IB. Let us solve exercise 4.1, question number 1. Express each of this complex number given in the exercise 1 to 10 this form of A plus IB. So this is this given a complex number, we have to express in this form of A plus IB. Solution. Given question is 5i into minus of 3 by 5i. Okay. So 5 into minus 3 by 5 into I into I. First we are writing the real parts, then we are multiplying I into I. 5 we can get cancelled. Then minus 3 is the real value. Now I into I. I into I is nothing but I square. But we know I square is minus 1. So we are substituting I square as is minus 1. Here again minus 3 into minus 1 is plus 3. Now if we want to make it as is in the form of A plus IB, we can write it as is 3 plus 0, that is 3 plus I0 is in the form of A plus IB where A is equals to 3 and B is equals to 0. Let us solve question number 2. I power 9 plus I power 19. Solution. I power 9 plus I power 19. For any integer, I power 4k, we know as a 1. I power 4k plus 1 is I. I power 4k plus 2 is minus 1. I power 4k plus 3 is minus I. Now, let us write this as I power 9 as is 4 into 2 plus 1. So, this is in the form of 4k plus 1. Okay. So, this should be replaced with this I. Next, 19 can be written as 4 into 4 plus 3, that is, which is in the form of 4k plus 3, that is minus I. So, I minus I, that is I minus I is 0. Again, we can express this 0 plus I0 is in the form of A plus IB, where A is equals to 0 and B is equals to 0. Let us solve question number 3. I power minus 39. Any power minus is there means that should come into the denominator. For example, x power minus 1 means 1 divided by x. X power minus 2 means 1 divided by x square. This we have to keep it in mind. Solution. Given question is I power minus 39. So as we know the power is minus, so we have to bring to this denominator. So let us first bring to this denominator 1 divided by I power 39. Now we know the formula here. Again, I power 4k is equals to 1, 4k plus 1 is equals to I, 4k plus 2 is equals to minus 1, 4k plus 3 is minus I. Now let us express 39 in multiples of 4 plus addition of a number. So we can express it as I power 4 into 9, because 39 we can write it as 36 plus 3. 36 is 4 9s is 36. Okay, so 4 into 9 plus 3. So this is in the form of I power 4k plus 3, that is minus I. So 1 divided by minus I. When denominator minus I is there, let us multiply with this I, both numerator and denominator. So we are going to get as 1 into I divided by minus I into I. That is 1 into I minus of I into I is I square, but we know I square value is minus 1. Therefore, we are replacing I square as minus 1 in the denominator. So we are going to get as I minus into minus is plus 1. So the value here is I. As we are substituting I square as minus 1, and therefore 1 into I divided by 1, that is I, 1I. We can express this 1I as a 0 plus 1I. So E is in the form of A plus IB, where A is equal to 0 and B is equals to 1. Let us solve question number 4. Express each of the complex number given in this, say this one, question number 4. 3 into 7 plus IB, whenever the brackets are there, we have to consider this is a multiplication for the entire the two terms, plus I into 7 plus I7. Solution. Given question is 3 into 7 plus I7 plus I into 7 plus I7. So first let us multiply with the 3, with the two numbers. 3 into 7, again 3 into I7 plus I into 7, I into I7. Okay, here 3 7s are 21, 3 7s are 21, I is there. Again 7 into I is 7I, here I into I is I square, so 7I square. But we know I square is minus 1. So let us substitute I square as minus 1 here. So 21 plus 21I plus 7I, 7 into minus 1. That is, now let us separate it to the real parts and imaginary parts. So 21 minus 7 is this real part, and the imaginary part is I into 21 plus 7. When we are taking the I common from this two terms, so we are going to get 21 plus 7. So 21 minus 7 is 14. 21 plus 7 is 28. So 14 plus I 28, which is in the form of A plus IB, where A is equal to 14 and B is equals to 28. Let us solve question number 5. We need to express this given problem in the form of A plus IB. Given one is 1 minus I minus of minus 1 plus I6. Okay. Solution. 1 minus I minus of minus 1 plus I6. So let us separate it out the terms. 1 minus I, minus into minus plus. So here writing is plus 1 here. Again minus into plus is minus, minus of I6. Now let us take the real part separately and the imaginary part separately. So 1 plus 1 is here, it is a real part, and let us take this minus I as a common here. Then 1 plus 6 is this imaginary part. So let us write here 1 plus 1 is a 2 minus 7I. This is in the form of A plus IB, where A is equal to 2 and B is equals to minus 7. Let us solve question number 6. 1 divided by 5 plus I into 2 by 5 minus of 4 plus I into 5 by 2. Solution. 1 divided by 5 plus I into 2 by 5 minus 4 plus I into 5 by 2. So let us separate it of this bracket to the minus, so that 1 divided by 5 plus I into 2 by 5 minus 4 minus of I 5 by 2. Now here let us separate real parts. 1 by 5 minus 4 plus 2 by 5 minus 5 by 2 into I. Let us take LCM for the real part, that is 5. So we are going to get as 1 into 4, 1 minus 4 into 5 divided by 5 plus I into, here LCM is 5 into 2 is 10. Okay. So 2 2 is 4 minus 5 into 5 is 25. So we are going to write it as 1 minus 20 by 5 because 4 5 is 20 here. Okay. 1 minus 20 by 5 plus I into 2 2 is 4 minus 25 by 10. Now 1 minus 20 is minus 19. So minus 19 by 5. 4 minus 25 is minus 21. Minus 21 by 10 I. So this that is equals to minus 19 by 5 minus of 21 divided by 10 I, which we can't further again simplify it out. Though this is in the form of a plus ib, where a is equals to minus 19 by 5 and b is equals to question number 7. Solution. Here the given question is, we need to express this brackets of that one. 1 by 3 plus I 7 by 3 plus 4 plus I 1 by 3 minus of minus 4 by 3 plus I. That is, first let us simplify this real part separately and imaginary part separately here. So 1 by 3 plus I 7 by 3 plus 4 plus I into 1 by 3 minus into minus plus. So plus 4 by 3 minus into plus minus minus I. Now real parts are here 1 by 3, 4 and 4 by 3. Let us write this real part separately here. Next imaginary parts are 7 by 3, 1 by 3 and minus 1. So we are writing it of this real part separately and the imaginary part separately. Now we are taking the LCM for the real part, that is LCM is 3. So 1 plus 4 into 3 plus 4. For the imaginary parts also again 7 plus I into 1 into 3 divided by 3. So here 1 plus 4 3 is 12. So 12 plus 1 is 13. 13 plus 4 is 17. So 17 divided by 3 plus here 7 plus 1 8. 8 minus 3 is 5. 5 by 3 I. So we are going to get as 1 plus 12 plus 4 divided by 3 plus I plus 7 plus 1 minus 3 divided by 5. That is 17 by 3 plus 5 by 3 I, which is in the form of a plus ib, where a is equal to 17 by 3 and b is equals to 5 by 3. Thank you.